video. In this video, we'll be looking at a topic called electrolysis, which is which has a bit of subject matter to be covered. Okay. So the learning outcomes after watching this video, you know what electrolysis is, by definition what it is, and how it works. There are certain terms that you have to learn, so you get familiar with all those terms. Then we will look into the electrolysis of molten ionic compounds, and then electrolysis of aqueous solutions, and then we'll look at certain applications in which electrolysis could be used, and which we can call them as uses of electrolysis. All right. So the first part, what is electrolysis? Electrolysis is basically it's a process where you have an ionic compound. If you want to break it down into their respective ions using electricity, then we call the process as electrolysis. But if we, so in terms of electricity, what we do in normal laboratory will be using the source of electricity to be a general cell, a battery or a series of cells. Okay, so the picture down there is the basic representation of a electrolysis setup, which you will see now in all of the electrolysis experiments. So this is the cell which we are using here, which we have illustrated here. It has a negative terminal and a positive terminal, as all other battery cells do have. And then you have a container like this, and then you could see that there are two rods-like things, right? So these rods are we give them a term. We name them as electrodes. Okay, so these electrodes are mostly or mainly, most commonly made out of carbon and platinum, because those are inert and they are not reactive with any other substance that we are trying to do the electrolysis. All right. Then we would have now these two rods. There are two rods. The intentional two rods is, one is named as a cathode, which is just having the negative terminal, and the other one that is on the positive terminal is named as the anode. So basically, those are two terms that you need to know, because you are going to associate it with those two terms, cathode and anode. Okay, you would not tell it as a negative terminal and the positive terminal, but you associate with these two names. So be familiar with what is what. All right, and then you have the solution. In this container, there is a solution which we call it as the electrolyte. So basically, the electrolyte will have the particular compound, the ionic compound that you're looking to electrolyze. So it could be any ionic compound. It could be copper sulfate, sodium chloride, sodium hydroxide, anything which we are looking forward to perform our electrolysis, break them into the particular ions, and gain the product. So all of that we will talk in the next slide. So these are the few important things with regard to the simple basic setup of every electrolysis experiment that is performed. All right. So be familiar with these terms, new terms, but be familiar. Next, we are going to have, the next slide, we'll go and look at the electrolysis of molten ionic compounds. Now, you need to understand this fact really clearly. Now, when we talk about electrolysis, we are actually talking about moving ions. Okay, so we know basically ionic compounds is a combination of a positive ion and a negative ion. Okay, but in order for electrolysis to be performed and for us to get what we desire, what we need to do is we should be able, these ions should be capable of moving here and there. the state in which they are, it is very, very important. So for electrolysis to be performed, all of these ionic compounds need to be in a state where these ions can freely move from one place to another. Basically, in other words, you should have the positive ions moving towards the cathode, which is the negative terminal, and you need to have the negative ions moving towards the anode, which is the positive terminal. So with that in mind, we need to understand that electrolysis cannot never ever be performed with ionic compounds in solid state. They should be either in molten or aqueous state, because in both of these states you will see uh, ions are free to move here and there. All right. So here we will look at first of all we'll look at the electrolysis of molten ionic compounds. So you can see the basic setup again, basic setup here, which we saw in the previous slide also. And here we are trying to electrolyze a molten zinc chloride. Okay, so as you know by now that zinc has a charge of 2 plus, and chlorine, the ion of chlorine will have, the chloride ion will have a negative charge. So what happens is the electro solution here, what we're going to put in the electrolyte will be zinc chloride. So when we put a solution of zinc chloride into here, the molten zinc chloride, what happens is, and when we pass electricity, these respective ions move towards the respective electrodes. They get attracted. Basically, the positive ions get attracted to the negative cathode, and the negative ions will get attracted to the positive anode. And therefore, there is going to be a reaction that's going to happen. So when this reaction happens, the most important thing in understanding this electrolysis is the very key thing is to know these reactions. In electrolysis, there are what we call as half reactions. So this image that you see here, the image that you see here on your this box, these are called half reactions. Why do we call them half reactions? Because we are writing one reaction that happens at one electrode and the reaction that happens at the other electrode. So we are writing both the reactions that happen at both of the electrodes. Okay. So now, for example, let's see what happens at the cathode. Now here towards the cathode, what will move on? What will move? The ion zinc 2 plus will move. The zinc 2 plus is a positively charged ion. So what will he do? He will definitely gain 2 electrons and become in the stable position, stable form, which is zinc, right? And then at the anode normally the negative ions should get attracted to that particular electrode. So chloride ions get attracted, and as a result, now chloride ions what does chloride ions like to do? They will always like to donate their 2 electrons. So they are the ones who would donate the 2 electrons and become stable as chlorine Cl2. So these are the reactions that happen in these 2 electrodes. And the most important thing here is you need to add the state symbols. I tried my best to find the picture which has, with state symbols, but unfortunately I wasn't able to find. So note here, the ions zinc and chloride are in liquid form. So that means zinc 2 plus and chloride minus ions are in liquid form. How do I know that? Because in this topic itself, we say electrolysis of molten ionic compounds. All right. And then the product zinc is solid. Why do you know? How do you know that zinc is solid form? Because zinc is a metal, and definitely it should be in solid form. All right. And then we have the product chlorine at the anode that is formed. Chlorine is normally associated as a gas. So chlorine is in gaseous state in this product. So be mindful of this. This is very important because and take a look here. Now at the cathode, what we have to do is we have to just balance the charges only. So zinc 2 plus is here, zinc is here, and we have to balance for the charges and we balance for the charge. But if you look at the anode reaction, because we don't just have to balance for the charges, but we have to also balance for the molecules. So that's why we have added a 2 here. So basic chemistry of balancing comes into play here also. So be mindful of that and remember how to write these half reactions. Small idea I could give you here when realizing about these. If you are finding, if you're like small trick, I would tell you. Now, normally at the anode, at the cathode, normally reduction happens. That means zinc 2 plus, which has a oxidation number of 2, will become 0 as it becomes a zinc metal. Okay, and at the anode, normally oxidation takes place. Okay, so keep that also in mind, and you can use that in a good way during examination. And one more thing. Now here you will see, here you see 2 chlorine minus 2 electrons. So if you don't want to associate any minuses, you only want to associate pluses in your equations, then you can simply move this minus 2 onto this side, which becomes a plus 2. Okay, or else it's simple mathematics. What we're going to do? How do we cancel these 2 electrons? What you do? You have to just add 2 electrons. If they get cancelled out, if you are adding 2 electrons to one side, then you have to add 2 electrons to the other side too, right? So then it will become 2 chloride minus gives you chlorine 2 plus 2 electrons. Okay, so what either way that's comfortable for you, you can just proceed with it. All right, next slide. So now we come to electrolysis of aqueous solutions. Okay, now when we consider about aqueous, what aqueous solution means is, now when we spoke about molten states, now in the previous example zinc chloride, in the solution of the electrolyte, you will only have zinc 2 plus ions and chloride minus ions. Okay, but when it comes to aqueous solution, there are 2 more additional ions that are present in the electrolyte. Okay, so those are the H plus ions and the OH minus ions. Okay, so it comes actually from the water. H plus and the OH comes from the water. The aqueous means you mix the solution. So in this case, we have this solution which we're trying to do the electrolysis, and it is in aqueous state. So that means apart from those 2 ions, we also have water also is present in that. All right. So with that in mind, we are going to perform the electrolysis of aqueous sodium chloride. So what happens is, now you can see there is a now when you have a lot of ions present, now Na plus ions, H plus ions, OH minus ions, and chloride minus ions, then you need to understand which of these ions are going to move to which cathode, like because there are now cathode normally the positive ions move, but here we have 2 positive ions, so we need to figure out which one will move to the cathode. Okay, so there's a selection. So in that case, what happens is actually if you remember the reactivity series, the lower reactive ion will definitely displace earlier or more preferably and move towards the cathode. So H plus is definitely lower in reactivity when compared to sodium, so it will move there and perform the reaction at the cathode. Whereas at the anode, you will find chloride moving towards the anode, and it will perform the respective oxidation reaction and give us the desired products. Whereas the other 2 will just remain at the bottom, and there's a tendency of them also making a particular product, which we'll look into in the next upcoming slides. So here also be mindful of this note that I have put here about the state symbols. So H and the Cl, H plus ion and Cl minus ions are in aqueous state. Remember, Aq is the symbol for aqueous. And the product hydrogen, the H2, definitely in gaseous state. And the chloride gas here, the chlorine gas, is also in gaseous state. Keep that in mind in a uh, in aqueous solution, that's the thing you have to keep in mind because there are multiple ions. So you need to determine which ion goes to which method and why. Okay. So we move on to the next slide. Now we come to the applications of electrolysis, or you can say the use of electrolysis. So the first use will be electrolysis of brine that you're going to look at. So brine is basically concentrated sodium chloride. So when you try to uh, electrolyze concentrated sodium chloride, you are able to see this reaction is happening. Same reaction as we looked at the previous slide, but here we have to add certain things. Now these two reactions will be very familiar to you all because in the previous slide also we did take a look about these two half reactions, so that's not a problem. But remember, I told you that when the H plus moves on to the cathode and when the chlorine moves on to the anode, okay, there are two more ions that are left at the left in the container. So those two ions will be sodium plus and hydroxide minus. So what they do is they will react with each other and they will form a product as sodium hydroxide. So in this electrolysis of brine, we don't just have only two products. We don't just have only hydrogen and chlorine, but we have a third product as sodium hydroxide. So each of these hydrogen, chlorine, and sodium hydroxide have their respective uses in real life. For example, sodium hydroxide is widely used in when we make soap. In soaps, sodium hydroxide is necessary. And the respective other gas that are formed, chlorine gas, hydrogen gas, they are also very useful gases in various industries in the world. All right. So this is a very beautiful diagram. Look at here. This diagram has something called a like a separation here. We call them this is a diaphragm. You could call it a partially permeable diaphragm. So these ions can move here and there and travel here and there and perform the electrolysis successfully. Not a big deal, not a big thing. Just keep this in mind. All right. Next slide. We come to another use, which is called electroplating. This is this is a bit of a say advanced concept which we are able to do using this principle of electrolysis. Okay, so basically the same setup. You have a cell, you have electrodes, you have an electrolyte, and all of those are set up. But there's a difference in what we have to do. Now, when we electroplate means we have an object. Say we have a spoon or a fork or a plate, and we want it. Now, the particular plate, it could be, I don't know, maybe it's say we have a silver plate, and you want it to be converted into a gold plate. So what are we going to do? How are we going to perform this? So what we have to do is we're going to attach the object that is supposed to be plated onto our cathode. All right, and then we have the anode with the metal that we want. So it could be gold. Say so we wanted gold in this case. So we have gold as our electrode for the anode. Okay, and then we have our solution. The electrolyte it could be anything. It's just to be a solution of the soluble compound of the metal. So in this case, the metal that we are looking forward is gold. So it could be any soluble compound of gold, any compound of gold. So then there's a reaction that takes place in that. So here in this diagram you can see. So the reaction takes place, and finally our desired product of this object, maybe a plate or a spoon, has turned into gold color. So that's basically electroplating, and it's a very interesting thing, and it's very interesting to see this. If you have the facility of doing this in person. All right. Finally, we come to the last slide, which is we will discuss about electrolysis of aqueous copper sulfate. Now, someone would ask, why are we doing this? There is a reason, because there is a small twist in this that we are about to look at. So in the first diagram here, we are trying to perform the electrolysis on aqueous copper sulfate by having the electrodes as carbon. So our electrodes are made up of carbon. Okay, normal carbon, we always talk about carbon. We said that our electrodes are widely used because they're inert, unreactive, and all of that we did say. So we are performing the normal way. So when we perform the basic fundamental way, we are able to achieve. Now, because this is a aqueous copper sulfate solution, what you will have in your the ions present in the solution will be copper 2 plus, SO4 2 minus sulfate ions, and then H plus ions and OH minus ions. So what will happen is copper will move on to the cathode with Y, because that by now you should be knowing why is like that. It will move on to the cathode and perform the previous reaction. So you can see copper will be formed here, right? We can show you. Okay, so you can see copper 2 plus will gain 2 electrons and become copper, and hydroxide ions will move on to the anode and perform the particular reaction and obtain water and oxygen as a result. Okay, so this is the complete reaction that is formed in there. But if you don't want to follow the fundamental way and you want to make a small change, so you can make a small change in this reaction experiment by replacing the carbon electrodes with copper electrodes. So when that happens, does that make a difference? Of course, it makes a difference. The difference that it makes is the reaction at the cathode remains to be same, no problem. What is going to happen? You will see the copper being deposited at the cathode, and at the anode you will see the anode, losing its copper and most of it producing the copper 2 plus ion. So what happens here is, now initially, before you turn on the electricity and everything like that, before you do this experiment, you see the two electrodes will be at the same size. But as the reaction goes on, as an accumulation happens at the cathode, the size of this electrode becomes bigger and bigger, larger and larger as it goes on. Whereas the anode, it becomes smaller and smaller as it is losing its copper, and the copper that is lost from the anode is being deposited at the cathode. Okay, so you can see the size ratio at the end of the reaction, the end of this electrolysis process. It's a very big difference in their sizes. Okay, so these are very two different experiments of the same compound, and you can see that different products are being formed, right? So this is very interesting. Science is very interesting. Okay, so with that we conclude our video. This is it for this video on electrolysis. So in this video we learned what electrolysis is. So electrolysis is breaking down of ionic compounds using electricity into their respective ions. And we also learned that electrolysis can be only performed on ionic compounds in states where the ions can be easily moved from one place to another. So they can either only be molten state or in aqueous state. All right. Then we also looked at the simple setup of electrolysis setup, right? So we looked at it and we determined new terms such as cathode, anode, electrodes, electrolyte, and all of these terms. Be familiar what these terms mean. And we also understood that that when we perform these reactions in electrolysis, we come across two reactions, which are called half reactions. One reaction happening at the cathode, where the other reaction happens at the anode. So I told you that at the cathode, you will always see a reduction reaction, where at the anode, whereas in the anode, you will see a oxidation reaction. Okay, that is one thing. And then we look at what happens when we electrolyze molten ionic compound. We saw that you will only have the respective ions moving to it. We don't have any extra ions. So if you're having to electrolyze, say, sodium chloride molten, you will only have sodium plus ions and chloride minus ions in the electrolyte. Whereas when you want to electrolyze an aqueous solution, you have to also keep in mind that there are extra ions, H plus ions and OH minus ions that come from the water. So you also have to be mindful of. So after that, we looked at the uses of electrolysis. We looked at electroplating. We looked at the use of brine, right? So brine was more easy for you all, right? Whereas electroplating was a new phenomenon that we learned. And finally, we looked at this electrolysis of copper sulfate, and we saw that when you change the electrodes, you are able to obtain different substances at the respective electrodes. All right. And be mindful that in all of these cases, we need to add state sequence. Be very, very mindful of that. All right. So that's it for this video. I will meet you in another video. Thank you. Thank you for listening, and I'll see you in another video.